These are extra specific heat problems. For number one, it says how many joules of energy must be absorbed to raise the temperature of 20 grams of water from 25 degrees Celsius to 30 degrees Celsius. And it says the specific heat can be found on your periodic table. We've been working with water for a while, and we should know that it's 4.7 joules grams degrees Celsius, and we're showing our work in for every statements. So in order to write this as a for every statement, it would be for every 4.17 joules is needed to get 1 gram of H2O to change 1 degree Celsius. So you need 4.17 joules to get 1 gram of H2O to move 1 degree Celsius. And now it's telling us the amount of water we're working with is not 1 gram, but 20 grams. So here we're multiplying by a factor of 20. And the amount of temperature change, which we can see, 25 to 30 degrees Celsius, is 5 degrees. So it's not 1 degree Celsius, but 5 degrees Celsius, so we're multiplying by 5. 20 times 5 is 100, and we should get 417 joules as our answer. For number 2, a 50-gram sample of some unknown metal warms from 18 degrees to 58 degrees Celsius. So warming means that this is T initial and T final after absorbing 800 joules. So what's the specific heat of this metal? And it also tells us that it's a 50-gram sample. So here are all of our unknowns, or rather knowns. We have 800 joules, we have change in temperature, and we have the amount of grams. So for every 800 joules, it is needed to get 50 grams of this metal to move 40 degrees Celsius. So this is the information we got from the problem itself, and it's asking us for the specific heat of the metal. Now the specific heat is always a certain amount of joules for 1 gram moving 1 degree Celsius. That is not what we have right now, because we have 50 grams and 40 degrees Celsius. So 50 grams, we're going to need to divide that by 50 to get 1 gram, and 40 degrees to move to 1 degree, we would have to divide that by 40. So dividing by 50 and dividing by 40, what we're essentially saying is it's 800 divided by 2000, and we get 0.4 joules to get 1 degree of the metal to move 1 degree Celsius. So this right here is our specific heat. And then the final problem. The specific heat of carbon, graphite, is 0.71 joules per grams degree Celsius. How much energy is given off if a 2-gram piece of graphite cools from 120 to 20 degrees? So 120 is the T initial, and the T final is the 20 degrees. So the change in temperature is actually a negative 100 degrees Celsius. We just need to know this conceptually later on to solve this actual problem. So let's write out our knowns in a for every statement. So we know the specific heat for every 0.71 joules to get 1 gram of the graphite to move 1 degree Celsius. Now we have the amount for the temperature, which is negative 100 degrees Celsius. We have the amount for the grams, 2. So we're multiplying by 2 here, and we're multiplying by negative 100 here. And what we would do here is multiply by negative 200. So what we should get is negative 142 joules. Now, that's the right answer when you do the math, but you wouldn't necessarily have a negative amount of joules per se. However, that negative should tell you something. It means that 142 joules are given off. So that negative is just for us to know that this is exothermic. And if you read the question, you see that it is an exothermic reaction because they're asking for how much energy is given off. So it's 142 joules that are given off, or negative 142, which would also relay the same information that it's exothermic.